finding you is the next part. Justin did. Okay. Anyone else come in since I called roll? Okay. Good deal. Okay. I think, yeah, we are now recording, right? Yeah, there's a symbol. Let's get this slideshow from current slide. Okay. Yeah, this is slow. All right, I have to get out of presenter view and then get into the better view, but it's not doing anything. Ah, wrong button. All right, I think we're here. All right, any questions for anything we've covered so far? Okay. We were talking about factoring perfect square trinomials, and we had done a couple. Let's see. It's Jackson, right? Okay. Anyone else coming since I called roll? Okay. Okay, we aren't quite there yet. Okay. This has the most room on it, so this is where we'll work, I guess. If there are no questions, where we left off last time, oh, by the way, I've got to wait. This set up. So many steps. Okay. All right. Here is a trinomial. 9x squared minus 30x plus 25. If you were asked to factor that, what would be your approach? Sorry? Factor it? How? How would you proceed? Okay. It sounds like you're going to unfoil it, to use my silly terminology. So yeah, put the parentheses down there, and then what would you do? Okay, I got that part down. Say again? Okay, you certainly could do the AC method. You want to review that? How do we do AC method? Second? Ah, okay. He's lazy. He doesn't want to go through all that work to do the AC method. He wants to do something simpler. And what did you say? Perfect square trinomials. At least it's worth a shot. What makes it worth a shot? When you first look at this, what do you notice? First term's a perfect square. Last term's a perfect square. If it fits that bill, give it a shot. Okay, give it a shot. Let's imagine that's 3x. Since we wrote this down this way, I wouldn't normally, but you could. 3x there, 3x there. And since the sign in the middle is minus, what does that tell you? Yeah, both of these are going to be minuses. And then what would follow those minus signs? 5 and 5. Okay? Don't know if it works, but let's see. Since we wrote it this way, you can foil it and see if that works. 3x times 3x is 9x squared. That's good. Minus 15x is minus 30x, and then plus 25. Yes, that works. If we just wrote it down as a square of a binomial, which this is, we could have just said square the first term, twice the product of these two, square the last. Yes, that works. Okay? Or you can pull it either way. Okay? So yes, when you see that first term, perfect square, last term, perfect square, remember it's got to be a plus, then give it a shot. See if the perfect square trinomial will work. It may not. Let's see if it will. All right. Good deal. Nice and lazy. Okay. Now, let's look at the two above here. They've already done the work. I don't like that. Okay. What do you think of this one? Worth a shot, perfect square trinomial, what would that be? 2x plus 3 squared. Let's see if that works. 2x squared is 4x squared. Twice the product of 2x and 3. What's 2x times 3? 6x. Double that, you get 12x. Got it? Plus 9. Yes. 2x plus 3 squared. Perfect. We just did that one. Why are they doing it again? And I think we probably did that one last time. Okay. These are perfect square trinomials. 3x minus 5 squared. How to check that? Square the first. 3x squared is 9x squared. Multiply these two together. Minus 15x. Double that. Minus 30x. Square the last 25. Yes, that works. Pretty easy to do once you recognize those perfect squares and see if it works. Okay, I got it. 1 second. No, I'm just kidding. Okay. Got it? Anybody else? All right. So, that finished perfect square trinomials. Let's go to example 12. Let's factor each one of these babies, if we can. Okay? What you think of the first one? It looks like it sure has that possibility. What would it be if it is a perfect square trinomial? X plus 7 squared. Let's see if it works. How do we do that? Square the first. X squared, that works. Say again? 7x times 2 is 14x. Got it? With a plus, yes. And 49. Yes, yes, yes. Okay, how about that next one? Okay, we hope anyway. All right, and what would that be? N, what? Minus 8. Let's see if that works. Okay. How would you check it? N squared, got it. 2 times 8, 16, minus 8, minus 16n, got it. Plus, minus negative 8 times negative 8 is positive 64. Yes. Yes. Uh-huh. Yeah. Yeah, positive 64. 8 times 8 is 64. Okay, in the middle, no, it's these two. N times negative 8 is negative 8n. Double that is negative. Yeah, you're not squaring it, you're doubling it. Minus 16n. Yeah. Yeah, the rule is when you got a binomial squared, square the first, twice the product of the two, square the last. Exactly. Right. That's the easy way. If you forget that, write it out as n minus 8 times n minus 8 for it. You'll get the same thing. Just a little more work, and Jackson's lazy. He doesn't like to do work. Okay, so, all right. How about that next one? Say again? Okay. Someone thinks it might be a 6a in there. A plus a 5b. Oh, could that work? Squared? Let's see. Check it and see. Six a times 6a is 36a squared. That fits. Multiply them together, you get 30ab. You do what? Double it. That would be 60ab. Plus 60ab, that works. 25b squared. Yes, yes, yes. Okay, how about that last one? A little louder. I heard a 4 mumbled. Okay. 4x minus y. Why not? Okay. Squared. Okay. Does that work? 4x squared is 16x squared minus 4xy. Double that is minus 8xy. Yes. Plus y squared. Yes, yes, yes. All right, good. Y'all caught on really well to that. Okay? Let's see how they did it. That first one, they did a lot of extra steps there, but that's fine. They're not lazy like Jackson. Okay? They're doing the extra steps. It's perfectly fine. And sure enough, that gives you x plus 7 squared. Y'all saw it right off the top. Y'all look better than that. I mean, y'all are good. Okay. Let's look at B. Okay. If that is helpful to spread it out this way, spread it out that way. It's perfectly fine. I'm sort of making fun of them, but it's fine. That maybe shows it more clearly than the other. Okay? See what it is? You got this one squared, twice this one times that one, and this one squared. So yeah, that makes a lot of sense. If that helps you see it better, do it that way. Okay? And that comes out in minus 8 squared. Okay? The next one, big old numbers here, lots of letters and everything, and yet it works just the same way. The first one squared, twice the product of the two square roots, and the second square root squared, right, which is 6a plus 5b squared. And finally, 16x squared, that's 4x squared, minus 2 times 4x times y. That would be minus 8xy plus y squared. Super. All right, 4x minus y squared. Okay, any questions on that? Y'all ate that up really well. So let's look at a summary, sort of tying all these things together. Okay? You tell me, what do you look for first when you factor? Second? Greatest common factor. I like it. Always do that. It makes the whole thing easier. You can be lazy and do that. Yeah. Okay. As we have indicated, factoring is an important algebraic skill. We learn some basic factoring techniques one at a time, but you must be able to put them together in any order you need them. Okay? Let's review the techniques and consider examples to illustrate their use. Okay? As a general rule, always, always, always look for that common factor first. So in this problem right here, what would you look for? 3, an x and a y. Pull that out, and what do you have left? xy squared plus what? Plus 9, period. Got it. How about that next one? Second? Y plus 2 is a common factor. Pull that out, and what do you have left? X plus 5. She's already doing it right off the top. Good deal. Okay. After common factors, here's the next thing I do, and it sounds silly. I count the number of terms. Okay? If there are only 2 terms in that, after I've gotten all the common factors out, there's only 2 things you can have. The first of those is difference of 2 perfect squares. Check for that. If you got that, factor it. Keep factoring till they're all done. Or either the sum or the difference of 2 perfect cubes. Okay? Except for those, that's all she wrote. Once you get common factors out, you look for that. So if the polynomial has 2 terms, then the pattern could be the difference of 2 perfect squares pattern or the sum or difference of 2 perfect cubes pattern. All right, so what would that be? 3a minus 5 times 3a plus 5. You're good. How about this one? 2x plus 5. Yeah, 2x plus 5. Now, for that next term, forget about this over here. Just square this one, 4x squared. Opposite the product, not twice the product, opposite the product of these, minus 10x, and then square the last. It's a little easy to get that confused with perfect squares, but it's a different animal, so that's the rule for that. So once you get all the common factors out, and I was hoping one of you would say, look for common factors first. And I did, but I saw there weren't any. But you always look for those first. Makes your life a lot easier. And we like easy life, right? Yes, I'll never mind. Okay, next, if the polynomial has 3 terms. So we started with common factors, then we looked for 2 terms. Some are different, difference of 2 perfect squares, some are different of perfect cubes. If it has 3 terms, then you do your factoring trinomial. Unfolding, AC method, whatever it takes. The polynomial may factor as a product of 2 binomials, so unfold it, if you can. Example 10 presented concrete steps as opposed to brick steps, okay, for factoring trinomials. And example 7 is factored by trial and error. And then we had the AC method, the book that I did. Then you also had the perfect square trinomials. Okay. What do we do with that? What would you do? Say again?
I think the first one, I don't know. I don't know, 6N.
What's that?
6N, 5N.
Okay, yeah. So you're unfolding it, basically. Yeah, okay, exactly. And you can do a, it's 30n squared. Okay. There's no n. Oh, yeah. 5n times 6n is what he was saying. And that's exactly what they did. Then where did you look next? Sign of the last term. They don't have to be both be positive. They have to be the same. Look here, and that tells you they're both negative. And then we tried 1 and 5. This was trial and error. Okay? What I was trying to fish for to see if you want to do trial and error, and that's what you did, and you got it. You may have not gotten the terms in the right place, but that's what the error is about. Just keep trying till you get them right. But I was wondering, when you saw such big numbers here, if you might not want to do the AC method. You unfold it. That's trial and error. Sometimes AC would work. But since this only has one possible factorization, and this is a pretty common one, you might try, I would have tried trial and error, unfolding, and that's what you did. Okay, how about this one? Okay, got to be a t squared, right? T squared times t squared. Plus, plus 2 and plus 1. That's the only possibility. Check it by going back and foiling and make sure you get this, and sure enough you do. But then you always check and see, can I carry that any further? Can I factor that again? Okay. Remember what our only possibilities were for 2 terms? Difference of 2 perfect squares, that's a sum, and that's not a perfect square. This is a sum, but they are perfect squares, but it's not a difference. Or sum or difference of 2 perfect cubes, that's not a perfect cube, that's not a perfect cube, that's not a perfect cube. So no, nothing we have will do that. Yes? Okay, where did it, okay. You foil it and see, okay? But that's why I hate that they gave you the answers. I would have rather they let us work them out. Let's imagine that we can't see those answers. They're not there, okay? So, I think David said, let's try, he wanted to do trial and error. He said, let's try 5n and 6n. And then he looked at the sign of the last term. It was positive. That means these 2 signs have to be the same. Looking at the sign of the middle term being negative, it has to be minus and minus. Then you look at the 5. What's the only possible factorization for 5? 1 and 5. Now that's the one we'll try first, and it happens that it works, 1 and 5. Now how do you get the 31? Where did it go? Well, that's where your foiling will work. In fact, that's what you got to do. You don't have to do it, but I suggest you do it. Make sure you got the right answer. 5n times 6n, sure enough, is 30n squared. That works. Then we do the outer, that's negative 25n, negative 6n. That adds to negative 31n. Perfect. And then minus 1 times minus 5 is plus 5. Got it. Now, when you went back and checked, like if we had put the 5 here and the 1 there, we'd have gotten the wrong number. Switch numbers. If switching those two numbers didn't work, then you might try 3 and 10 here rather than 5 and 6. And then you might try 10 and 3. Or you might try 6 and 5. I mean, you just keep trying different combinations. You could go up as high as 1 times 30, you know. But when you did too many of those, I just about say, time out, let's go back to the AC method. That might save us some effort. Okay, but once you got that far, keep going until you can't go any further, then maybe try AC method. If you can't get anything, then you can say, not factorable. I think I told you before that on your quiz and on your test, there may be some that are not factorable. But guess what? Writing not factorable by all your questions and saying, well, I can't factor it, so therefore it's not factorable. No, if it's factorable, you have to factor. Okay. Never mind. All right, so that's the third technique. Common factors, count the number of terms. Binomials, left over after common factors. Difference of two perfect squares, sum or difference of two perfect cubes. Trinomial, unfoiling, AC method, perfect squares, whatever it takes. What if we have 4 terms? What do we do? Grouping, that's a great idea. Now, I would say for 4 or more, but for any even number of terms, 4 or larger, then factoring by grouping. If you have 5 terms, grouping isn't going to help you, okay? But factoring by grouping may apply. It may not, but it may. Now, remember also, though, just because you can't group it the first time, you might want to rearrange and try a different grouping. So, here's a 4-termer. What might you try on that? Yeah, group the first 2, and that looks like it'll work. Why? Common factors of A. Factor out the A times B plus C. Group the next 2, and what do you have? 4 times B plus C. Then you have a common factor of B plus C. B plus C times A plus 4. Got it. Now, finally, if nothing works, you've tried every technique and carried it all the way through, it may be it's just not factorable. This is last resort, though. Just because you don't see how to factor it, don't say not factorable, I can't factor it. Nope. If it's factorable, you have to factor it. This one, no common factors. Not a 2-term, but a 3-term polynomial. You might try unfoiling. Well, this could be, has to be x times x. This has a bunch of different factors. 3 times 4, 2 times 6, 4 times 3, 6 times 2, 1 times 12, 12 times 1. But guess what? Try all those, you're not going to come up to 5x. Can't work. In fact, the smaller the numbers are, 3 and 4, 3 and 4 would be 7. You can't get any smaller, okay? Never going to get a 5 there. So it's not factorable using integers. Good deal. Any questions on that? All right. That is the end of 3.6. Now, I think I told you this in the other section, but I'll tell you again. They have a little concept quiz here. They're always true-false. Don't expect to see anything like this on a test or quiz. You might 1 or 2 pop up, but usually not. But if you can work through these and get the correct answers, that's a good learning, a good practice skill. And how do you know if you got the right answers or not? Flip over 1 page, and there's the answer to the concept quiz, okay? So, problem set 3.6, this is where I would focus. Do any of the odds 1 through 29, okay? Do any of the odds 31 through 55. Do any of the odds 57 through 61, And then finally, any of the odds, 63 through 111. Are there enough there? Okay. Good stuff, Maynard. Now, if you want to try some of those thoughts in the words, that's fine. Don't expect something like that on the test, though. Further investigations, those get a little bit more complicated. And if you really like a challenge, you can go for those. You won't see that kind quite like that on the test. So, but you may find them interesting to do. Okay? Any questions on that? Now, technically, that's all we're supposed to do, but I have seen enough final exams to know that sometimes they put a little more complicated problems on those. So I think 3.7 is probably a good place to go. So let me clear this, and we will do 3.7. We'll try to do it pretty quickly. So let's do 3.7. It's a good section, but I don't think I put it in the syllabus that we would do it, but just looking at that and knowing the types of questions I've seen on finals, I think it's probably worthwhile to spend a little time on it. All right, what we're doing is equations and problem solving, which is what we love to do, right? Yes. Okay. It takes me a few minutes to get this set up. Sorry about this. Okay, now we're on the same page. All right, polynomials, same as before, equations and problem solving. We'll solve equations by factoring. That's why we did all that practicing, so we solve equations. Once we know how to solve equations, the reason to do that is so we can solve problems, okay? Because that's where real life is, in solving problems. The techniques for factoring trinomials, or any kind of, this is trinomials mostly, provide us with more power to solve equations. Now, I think we did this earlier. If you have the product of any two entities, these don't have to be letters or numbers or anything else, entities, any two things, multiplied together. If that product is 0, one of those things has to be 0, right? The zero product principle continues to play an important role as we solve equations with trinomials or however we do it. Let's consider this example. How would you go about solving that trinomial equation? Okay, say again. Wait, I've got to get this. Okay, what do you say again? Factor. Good answer. Okay. And remember, this now is an equation, so you got to keep that equal sign in it. Okay, the left-hand side is what we're factoring. And by the way, they set this one up perfectly for you. You need it equal to 0. If they had set this up equal to 17, you got to subtract 17 from both sides first, so it's equal to 0. So you always have to, don't factor it before you got a 0 on the other side. This one already did, so we're fine. All right, so how would you proceed to factor? X times x, that's a good first start. Different sign, so that tells you plus and minus, good. Now, say again. The greater term is negative, you got it right. You're looking for two factors for 12 that the difference is 11. With the bigger, say again? 12 and 1, there it is. You put the 12 with the minus sign and the 1 with the plus sign. I always check it to make sure I've done it right. Let's see. Foiling it, x times x is x squared, good. All right. Minus 12x plus x would be minus 11x, good. And these two, negative 12, got it. Now what do we do? Now set each of them equal to 0 separately. X plus 1 equals 0, or x minus 12 equals 0. That's that zero product principle. What do we do with the first one? Solve for x, and how do you do that? Subtract 1 from both sides, and that gives you x equal negative 1. Or add 12 to both sides, and that gives you x equal 12. Now, what I like to do is go back and make sure I've got it right. How you do that is plug it in, plug it in. Negative 1 squared is positive 1. Negative 1 times negative 11 would be positive 11. So you got positive 1 plus 11, that's 12. Minus 12 is 0. All right, that's good. How about this one? 12 squared is 144. Wow, y'all big numbers here. I think I'm going to have to write that one down. That's going to be 144 minus 11 times 12. Anyone know what that is? 121. No, that's 11 squared. 132. Check it. You got calculators, right? What is it? 11 times 12? Negative 132 minus 12. What does that add to? Say again? 0. Good. So that one works too. Okay, they both work. All right. Good deal. Everybody got that? Okay. I'm going to erase the ink so we can see how they did it. And lo and behold, they wrote it again. What a good waste of time. Okay, next. They factored it, and they got the same thing we did. X minus 12 times x plus 1, good for them. They set each of those equal to 0, good for them, 0 product principle. They solved that x equal 12 or x equal minus 1, good. Then they wrote it in solution set. Isn't that nice? Okay, yes. What sign you assign? Okay, yeah, good question. All right, let's start back up here. We put the empty parentheses right? First thing we start with x squared. The only thing is x times x. Okay. Then we look at the sign of the last term. That's negative. What does that tell you that these two have to be? Opposite each other. So you can put in a plus and a minus or a minus plus. It doesn't matter what order. They just got to be opposite. Okay? Okay, yeah. Don't look at this yet. Look at this to begin with. You jump from the first. See, we don't spell unfolding very well, okay? It's not first, okay, outer. We look at the last sign of the last term. And then look at this to see which of these factors has to be the larger factor. The minus one does. And that's what someone pointed out. I think it was Jackson pointed out. The larger number has to be the negative because this one wins. Okay? So then you look at all the possible factorizations of 12, because this is just x times x, and that could be 3 times 4, but if you put minus 4 plus 3, that would only be a minus 1. That wouldn't work. Minus 6 and a plus 2, that would be a minus 4. That wouldn't work. But if you do minus 12 and a plus 1, sure enough, that gives you minus 4. All right, good deal. And then checking is just the fun part. Any questions on that? Good question, by the way. All right, guess what? They skipped 2. They skipped 3. They skipped 4. They skipped 5. They skipped 6. You want to do those? Okay. That sounded so enthusiastic, I can't believe it. Okay. All right. Let's solve this one. 20x squared plus 7x minus 3 is equal to 0. You tell me how you want to proceed on that. Say again? Yeah, okay, good. How, though? That's what I was looking for. How do you want to factor it? Unfolding. Okay, we'll do that. Okay, now, a lot of different factorizations for 20x squared. Which one you want to try first? I like it. 4x and 5x. Let's go for it. 4x and 5x. Now, where do we look next? The sign of the last term is a which means these two have to be different. So one positive, one negative. Do you have a preference? Pick one. Okay. Okay. Second? Plus and minus. We'll try it that way. Okay. And then what's the only possible factorization for 3? 3 and 1. You want to write it that way? Oh, you're looking, aren't you? Okay, but you want 1 and 3. All right, let's see how well you did. This is why they call it trial and error. You try something, if it's wrong, try something else, okay? So let's start with this. 20x squared, good deal. Minus 12x. Plus what? Plus what? 5x. Minus 12x plus 5x is minus 7x. What's wrong? What's backwards?
5 needs to be positive.
Okay, the signs are wrong. The number's right. We needed a 7. The sign's wrong. So guess what we do? We change the sign. Don't change the number, just change the sign. This is my little rule, okay? Change that to the minus and change this one to the plus. Now let's check it again. 4x has 5x. 20x squared, that didn't change any. How about this one? Plus 12x minus 5x is positive 7x minus 3, you got it. That just gets it factored, okay? All that work and you're not even there yet. So now what do we do? Set them each equal to 0. 4x minus 1 equals 0, or 5x plus 3 equals 0. What do you do with the first one? Add 1 to both sides, and that gives you 4x is equal to 1. Then you divide by 4. X equal 1/4. Can we have fractions? Yes, we love our fractions. Right? Okay, good. Next. Subtract 3 from both sides. 5x equal negative 3. Divide by 5. And that gives us an ugly 5, isn't it? Okay. X equal negative 5, 3/5. I can't write, can I? Okay. Sorry about that. Now, say again? Yeah, I think I swallowed several times. Okay, never mind. Okay. All right. I think I'm hoping it's just allergies and not the start of something, but yeah, I don't know. Yeah. All right. Y'all are looking forward to doing this checking, aren't you? I can tell. Okay. This is going to be a little messy, but it's doable. Rather than taking class time to do it, I'll talk through it real quickly. You need to really practice this kind of stuff. What is 1/4 squared? 1 squared is 1. 4 squared is 16. That's 1/16. Times 20. Well, 4 will go into 25 times, 4 will go into 16 4 times, so that would be 5/4. Right? Okay, remember that, 5/4. Plus 7 times 1/4 is 7 times 1/4. Yeah, 7 times 1/4. Okay. I think in terms of food, okay? I picture a pie cut into fourths, right? And I'm doing to eat 1/4 of a pie 7 times. Oh, that sounds so good, doesn't it? So how many pies will I have eaten? There's 4. There's 3 more. 7/4 of a pie. times 7 is 7/4. So 5/4 plus 7/4 is 5/4 plus 7/4 is what? 12/4. And 12/4 is what? 3. 3 minus 3 is 0. Yeah, that works. If you think of food, it really works nicely. Okay. And if that was fun, how about this one? Negative 3/5 plug in for x. What's negative 3/5 squared? Negative 3/5 squared. Well, first tell me what negative times negative is. Say again, someone said something. 9/25. You got it. A negative squared is positive. That's 9/25. And this is 20 times that. Well, let's see. First, let's do 5 into 20 is 4. 5 into 25 would be 5. So that would be 9 times 4 is 36/5. Right?
It's probably better if you write it step by step.
Absolutely. That's what I'm saying. You go home and write it down.
Well, that's the thing, because you doing it in your head, and we don't even know what the follow.
Okay.
We don't know the step. I can't know.
You just want me to work so hard, don't you? I was wanting you to work hard. You know, that's the problem. He is too lazy. That's called too lazy. Yeah, no.
I have some of that diagram.
Okay. All right. So let's do it. That would be 20. And y'all already figured out that that would be 9/25, right? Plus 7 times a negative 3/5 minus 3. We wonder if that's equal to 0. We don't know. We hope it is. Okay, yeah. Are you just stretching or question? Okay. All right. Here's what I like to do, because I'm really lazy. I like to get the numbers as small as possible. 5 will go into 24 times. 5 will go into 25 5 times. So this gives me 36/5, right? Minus, because minus times plus is minus, that's 21/5. And what's 36/5 minus 21/5? $36 minus 21. Say again? 15/5. And what's 15/5? Yeah, 3. You're right. 3 minus 3. Yeah, right. Sure enough, it's 0. Okay. 3 minus 3 is 0. Okay. I just like the, so I can't help it. Okay. Good deal. All right. So, that's how you do it. All right. Am I all right to clear that? Y'all need a little more time with it. Okay. I thought you were taking my picture. Okay. Okay. All right. That was number 2. Let's look at number 3. So let's clear all that ink. Imagining it really was ink. It's ions. Okay. This one is negative 2n squared minus 10n plus 12 is supposed to equal to 0. All right. Now there's a couple ways you can go on this. If that were just a factoring problem, it's a little messy. But since it's an equation, you can clean it up if you want to. What do you not like about this? You love it all, right? Huh? Yeah, I don't like leading off with a negative either. So guess what I can do? Because it's an equation, I can multiply both sides of the equation by minus 1. Okay? And what will that make the first term? Okay, I'll actually write it down there. Multiply this by minus 1, and multiply this by minus 1. Okay, so that'll make this a 2n squared. Help me. Plus 10n minus 12 is equal to 0, because negative 1 times 0. Oh, that's what makes the equation so nice. Now I'm a lot happier with this one. What would you do next? Oh, why didn't I think of this before? Say again? Yeah, all of them are divisible by 2. So I could have just divided out a negative 2. What was I doing? Y'all should be watching me better than that, okay? Help me from making these silly mistakes. Okay? So you're going to factor out a 2. What does that leave you? N squared plus 5n minus 6 equals 0. Now there's 2 ways you can go here. You can either keep factoring or you could divide out the 2. If we had seen that earlier, we divided out the negative 2 and had it all done in one step. But whichever way you want to go. You want to keep doing it or divide out the 2? Doesn't matter. Second? Divide out the 2, okay? That's pretty easy to do. Divide this side by 2 and this side by 2. That goes away. And that would be n squared plus 5n minus 6 is equal, what's 0 divided by 2? 0. Okay, it's gone. Okay. Now, if you're just factoring, you can't get rid of it like that. But when it's an equation, you can divide both sides. As long as you don't divide both sides by 0. That's not very fun to do. Now what? Yeah, let's see if we can factor it. So how would you proceed with that? N times n, good choice. Do what? Plus and a minus, very good, because that last sign is negative. 6 and 1 in that order. The 6 with the bigger, because you want the bigger number being positive. Let's check it and see if she did it right. N times n. N squared. Negative n. Plus 6n would be positive 5n. Negative 6. You got it. It worked. Now what do? That just factors it. Set each equal to 0. N plus 6 equals 0. Or n minus 1 equals 0. What's that first one give you? N is equal to negative 6. The second one gives you n is equal to 1. Now, you could do the actual subtraction and addition and stuff. It works. Or you can look at that and say, what's the only n that when you add 6 is going to give you 0? Negative 6. Either way you do it. As long as it's right, you can do it. Say again? I couldn't hear you. Okay. 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 You want to do it that way? No. Why did they do it? Strange people, you know, that I don't know. That's the same as dividing by negative 2. That's how I would have done it. If I had looked at it carefully enough, rather than doing this, I said, oh, let's divide everything on both sides by negative 2. That gets rid of your minus here, and it reduces that. So that would have been a plus n squared plus 5n and a minus 6. That's the same as multiplying by negative 1/2. It's just, that looks harder, but it isn't. Yeah, okay, good question. All right, let's do number 4. Okay. All right, to erase this? Okay. Okay, he keeps telling me he's good. I don't know how good he is. Okay. All right. Here we have 16x squared minus 56x plus 49 is equal to 0. What are we going to do here? Second? Factor. Okay, good choice. So if it's equal to 0, how would you factor that? Aha! She noticed it was a perfect square trinomial. What gave it away? Or at least she hopes it is. The first term's a perfect square. The last term's a positive perfect square. So what's your guess? 4x minus 7. Okay. We hope that's going to be true. How do we check it? Square this one. 16x squared. Yes. Multiply them together, you get negative 28x. Double that. Negative 56x. All right, and then positive 49. So that does work. Now, since this is an equation, you might actually want to write that rather than as a square. You might want to write it as a this times itself, 4x minus 7. That's what it means to square something, multiply it by itself. Okay, what do you do now? Okay, 4x minus 7 equals 0, or 4x minus 7 equals 0. And what do you do to the first one? Add 7 to both sides. 4x equals 7. Divide by 4. X equals 7/4. I see everybody's wanting to check this right now, aren't you? Okay. But what happens on the other side? Same thing. So you don't need to do it twice. Okay. Now here was something. Most of the time when you have an equation that is the maximum exponent is 2, you expect to have 2 solutions. But not always. This one has only 1. Because it was a perfect square trinomial. Okay? There will be a few who will have no solutions. Okay? And we'll probably see an example of that. Okay? Did you want to check this or not? Okay. All right. It's checkable, but I'll let you do it at home. Okay. Isn't that what? That's what our professors used to say. And we'll leave this to the student. You know, the books love to say that. We'll leave the checking to the student. That means they don't want to do it. Okay. So that's example 4. Let's do example 5. Okay. What's that? So it's all right to erase? All right. So example 5. Goodness, I can't read in this light. 9a times a plus 1. Okay. Now, when I first look at that, except for my ugly plus sign there, is I say, oh, they've already factored it for me. Isn't that good? Guess what? No, it isn't. Why not? Because it's not equal 0. Okay? You don't have a 4 product principle. Yeah. You only have a 0 product principle. So guess what we got to do? Multiply through and then subtract your 4. So you got to undo this factorization you have. What would that give you? 9a squared plus 9a equal 4. And now what? Subtract 4 from both sides, so you will have a 0 over there. 9a squared plus 9a minus 4 equals 0. What's that? Oh, okay. What next? Let's see if we can unfoil that baby. We may or may not be able to. Let's see if we can. Where would you start? Let's try a 3a and a 3a. And then where do we look? Second? Sign. And what does that? And what does that tell you? These have to be opposite. So one's going to be positive, one's going to be negative. And then what do we do with the 4? Second? Okay. And what's going to be your larger factor? 4. Okay. She's going to use 4 and 1. You could use 2 and 2. Why would 2 and 2 not work? If you put a 2 here and a 2 here, what would that be? Yeah, that would be a sum times the difference of the same 2 numbers. That would give you a difference of 2 perfect squares. A binomial. This is a trinomial. That couldn't work, so therefore she chose to put 4 there. But we don't know if it's going to work until we test it. So let's test it. 3a times 3a is? 9a squared. That one works. Minus 3a is plus 9a. Look at that. And then negative 4. Okay. You got it. Are y'all awake yet? Okay, good. All right. Now what? So each equal to 0. 3a plus 4 equals 0. Or 3a minus 1 is equal to 0. And what does this give you? 3a is equal to negative 4. This gives you 3a is equal to 1. This gives us, oh, I'm sorry. Yeah, I'm sorry, I was doing, okay, this one's going to be a is equal to minus 4/3. And this gives you a is equal to 1/3. Okay, I'm sorry, I'm sort of going fast here trying to get as much done as we can. I know y'all want to check it, don't you? No! Okay.
So is it?
It's not that bad to check, but you plug in an A in the original problem, not in this part, this part, this part. Plug it in the original and make sure it works. Okay? Good deal. How are we doing on time? It's what? Oh, we have 3 minutes. Oh, boy, that's a lot of time, isn't it? Okay. I think that probably we wouldn't be able to get example 6 done. So we'll start next time on example 6. Is that okay? Okay, but that's an all, folks. Okay. We'll start there. Homework exercises, you could do any of the odds 1 through 53. And we'll pick up the rest of those next time. But that's not all, okay? Because you have a weekend coming up, and I knew you would really be cursing me like crazy if I didn't give you something to do over the weekend. So let me give you a quiz, okay? And that way you'll have some math to do, and you won't be bored all weekend long, and you'll think, oh, what a nice guy he was, okay? All right, so here's your first quiz, okay? Have one down. Okay? Pass another one down. And then you get one by yourself. Okay? Let me give you 3. Keep 1 and pass 2. Did you go? Yeah, you got one back. So, 3 pass back. You 2 pass on forward. Okay? And you 2.
You just write the answer over?
Yes. I'm sorry? Sure. For somebody else. Yeah. All right, let's go. What was the question? I know
We just write the answer. We don't work it out on here. What we do?
Okay. Good question. Let me go over that real briefly. I prefer to see the work. Here's why. If I see the work and you're doing in the right direction, I can give you partial credit. If all I see is an answer is wrong, guess what? That's just wrong. So I like to give partial credit. So I like to see work. So you can either do it on this piece of paper or a separate piece of paper, whatever you prefer. Now, it's not due until next Wednesday. That always gives you Monday to ask questions if you have questions, and then Wednesday. If you need more time, you can usually have it. But try to get it done as soon as you can. Good deal. Okay.